So for software vector mode and the core interrupts, and I think most people do use software vector mode, but it's up to you. This is the prefix that I mentioned, the IVPR. It's a special purpose register, and there's code on how to load it. We've got code to initialize it for you, so you can just use it. Gets added to the offset, and that's our vector. Okay, say the same thing here, just a little animation. Now, preemption. So we have 16 levels of interrupts. Every peripheral has to be assigned a interrupt priority if you wanted to enable interrupts. If you don't use interrupts, don't worry about it. But you have to select a priority, interrupt priority, for every peripheral that will be enabled for an interrupt request. And it can be from 0 to 15. 15 is the highest priority. 0 is the lowest. And if you're executing an interrupt service routine of priority 5, and you've enabled interrupts again, then only priorities 6 through 15 will be recognized. Only higher priority interrupts are recognized. And the same and lower will not be. So, quiz question. If I have a priority 0 interrupt for a peripheral, will it ever be recognized? How many say yes? No, I can't. I only recognize higher priority interrupts. So that's one thing I have to do, and you'll see in the code when I initialize a peripheral like the PIT, I give it an interrupt priority above 0. And so now, though, with these different priorities, I can have preemptions. So just to repeat, the highest priority is 15, 0 is the lowest, and every interrupt source, I have to set the priority in a priority select register. And the interrupt controller, when it's executing interrupt, will copy the priority of that interrupt into its own current priority register, save it, and will not recognize any other interrupt requests with the same or lower priority.
A question. Suppose you put the priority as 1 and another interrupt from 1 comes. Will it be recognized?
Not until the current interrupt finishes and the priority goes back down to 0. There's a little LIFO in there that as an interrupt completes, it pops out the prior one. And when a new interrupt comes in, it pushes it into the LIFO. So there's just a LIFO, transparent to you. You don't have to worry about it.
Will that happen even for priority 0?
Priority 0 will never be recognized because the lowest value for a priority, the current priority of an interrupt, is 0. And we only recognize interrupts with a higher priority than the current priority. What I'd like to do now is walk through, instead of having you look at by yourself, the PWM was kind of straightforward example. This one I want to walk you through the interrupt example because it's pretty key to understanding the structure, and I'm going to point out a few things. There are details you don't have to use, you can just cut and paste, but I want to go over them once now, and then you can either forget them or look up more information on them if you want to. In the application note, there is an example. Actually, there's 2 sets of examples for interrupts. The first 2 in there use the eMeos, and those are kind of the first ones I did. They're a little obsolete now. Use the second set that's, say, with the VLE mode, and this for the Bolero will use the VLE instructions and the PIT. So what we're going to do here is, if we look at the block diagrams, is we are going to, using a 8 megahertz crystal, we'll set the, like we did earlier, the system clock to 64 megahertz. And then we're going to run the pit. We're going to preload a value, and when the timer counts down to 0, it will generate an interrupt request. The timer value that we specified will be reloaded, and we'll get a repeating interrupt. And since the system clock is running at 64 megahertz, what I'm going to do is just load 64,000, and that gives me a 1 millisecond timeout. So the interrupt controller will get an interrupt request from one of the pits, well, from pit 1. And in the interrupt service routine for pit 1, every other time I'm going to invoke a software interrupt request, which is very simple. You write to a register and you generate a special register. You can generate a software interrupt. So now I have a 1 millisecond and 2 millisecond task. So here's how it works, the program flow. The interrupt is taken here, and I'm going to vector to, I'm going to have a branch table. And this branch table, you'll probably never have to change this file. Here's the file that it's in, ivor branch table vle.s. And so we will vector here, and we will go to ivor for handler. The prologue here will save SR, the prior machine state and address, which is in SR 0 and 1. It'll read the who did it, give me the vector number, and store that, and now I can re-enable interrupts for nesting. And then it'll save other registers as needed, and then it will branch to that ISR for that vector, which the first time will be the pit. And the pit, these ISRs are very simple. Increment counter. Maybe in this case, if it's an odd count, I invoke another interrupt, and then I clear the flag. And this is very important. Every interrupt will have a flag, and you have to clear it. Otherwise, you go right back to it if you don't clear it. And the way you clear it is not by writing a 0. No. You got to write a 1 to that bit. So you write a 1. Actually, the proper way to do it is write to the register, have all zeros in that register, and then just a 1 for the 1 bit you want to clear. So you'll see this all throughout the manual for interrupt flags. W1C. Write 1 to clear it. And that's what the code does. So I clear the flag, then I come back, restore registers, and then I do a return. And just before I return, though, I'm going to disable interrupts for a little housekeeping. Then I can return. So once again, the modes here I put down, and here's my steps here. I'm going to have a vector table we'll see in the code, but this is just like I did before, init modes and clock. The thing is, though, I'm going to have a peripheral control register for the pit, because now I want the pit to get a system clock. Remember, none of the peripherals will have a clock on power up unless you give it one for that mode and transition into it. So before I did the SIU, now I'm doing the pit. It's a different one. And I have to say, where is my interrupt vector table located? And so I load a register, and I'm going to specify that in my linker file. And I'm going to initialize the interrupt controller for software vector mode here. By the way, you can see these are different processor families in the Coriva processor family. Over here, you are here, MPC 56XXB, that's us. And then I have to initialize the branch table for the interrupt service routines as to where is that located. Now I initialize the pit. And so I enable it, and I tell it to freeze in debug mode, so don't keep counting. And all the peripherals have that have timed I/O have a freeze bit, so you can tell it, do you want to stop counting in debug mode or not? For example, do you want the PWM to stop when you have a debugger breakpoint or not? And so that's a freeze bit, and it's your option for each one. Then the PIT, I have to load it with a value. I load for 64,000, so that'll give me a 1 millisecond timeout. And now I enable it, and I enable the interrupt request, and I tell it, hey, when you get a flag, I want to request interrupt, not DMA. So I load that channel. Here we go. And I set my priority for the PIT. That's the last thing I do for the interrupt controller. Every PIT has its own priority select register, so or every interrupt. So I assign it to a priority 1 here, and then for software interrupt, this is a very simple dumb interrupt. All I have to do to initialize it is set the priority register, and here it's priority 2. So I've done all this, but out of reset, interrupts are disabled. And there are 2 things I have to do to enable interrupts. One is the machine state register has a bit to enable interrupts external to the core, the EE bit. I have to set that bit to 1. That's the right EE1 instruction. And the second thing I have to do is the interrupt controller only recognizes priorities higher than its current number, and the current priority number is 15 out of reset. So I have to set that to 0. Once I've done those 2 things, any interrupts will be recognized. So I just wait forever. Wait for an interrupt.